So now we're going to talk about one of the primary tools used for both rigging, skinning, as well as for animation, the joints, or sometimes called bones. For animation, this is the tool that they'll use to manipulate and pose their character. And this is done either through direct manipulation of the joint or by indirectly manipulating it through controls, which either drive it through a parenting scheme or with constraints. So typically you'll see animators rotating joints, although, it shouldn't be confined to just that. You can, effectively use all the transformations when rigging a character. But typically you'll see a rotation used. For rigging and deformations and skinning, it's through the transformations on this joint. And these transformations drive the position of the vertices or CVs of the character model based on the weight that's inherited from each of the joints in the hierarchy or rig. So what basically is a joint? I guess basically you can boil a joint down to a hierarchy of pivot points, either a single pivot point or a hierarchy of pivot points. So here, let's open up our hypergraph. Let's frame this. We can see we have two joint nodes. Each is basically a pivot point. If we unparent them, we can see that we have two separate objects. And how Maya determines how this joint affects the CVs or vertices of a model is through the transformations applied to this pivot point. This is quite similar actually to a simple parented hierarchy. Here I have another example to show what I mean by that. So here we have two 3-node hierarchies. One are joints, which are parented into a hierarchy, and the other are 3 polygonal cubes. Let's open our hypergraph once again. So here we can see the similarity in these. 3 joint nodes and 3 polygonal cubes. Display their local rotation axes. Just go ahead and fix this one here. So we can see, although they're oriented differently, they're basically 3 pivot points. So let's select and manipulate these and see what we get and to demonstrate how similar they are. So here we can rotate them and scale them. So I'm going to do a similar action with the parented cubes. Rotate and scale. So that way you can see how similar these two structures actually are. And one thing I've shown here is this local coordinate system, which is called a local rotation axis. This is something that you want to keep an eye on when building rigs. If this were a spine, for instance, an animator would expect to select these two joints, and when rotating them, to have them rotate in a predictable manner. I'm going to switch to component mode and actually flip this local rotation axis arbitrarily. Return to object mode, let's select it, let's rotate it on Y, and here you can see we're getting a totally unpredictable rotation. So by making sure that your local rotation axes are all aligned properly to give you the rotation that an animator will be expecting, that's one thing that will help ease the animation process as well as control the deformations and motion of your character's hierarchy. Another interesting thing with joints is rotation order. I'll switch back to our single joint here. Every object, every DAG object in Maya which can be transformed has a rotation order. Let's open up our attribute editor. And here we can see in rotate order, it's set to X, Y, Z. And what this means is this is the order from top down that the rotations are evaluated on this character. So let's display our local rotation axis. And we can demonstrate the importance of the local rotation axis by putting this joint into a situation that's called gimbal lock. What gimbal lock is basically is when a 90-degree rotation is applied on a joint, depending upon the rotation order, you can lose a degree of freedom by aligning two of the three axes with one another. And that can happen, for instance, this joint is in an XYZ rotation order. So if we were to skip the X rotation and go directly to Y and rotate it 90 degrees, we can see that we still have our Y rotation, but our X and our Z rotations are aligned with each other. And if we return to the original position of the joint, we have 3 degrees of freedom. There's X, there's Y, and there's the Z rotation. But by bypassing the first rotation in the rotation order and putting a 90-degree rotation on Y, then we can see that we've aligned the Y and the X rotation. So they're both pointing down the length of the joint. Gimbal lock is something that you'll need to be aware of, particularly in areas such as the hip, but more so in the shoulders, where a character with the ball joint configuration can easily put an arm into a gimbal lock situation. And although with Euler rotations, gimbal lock is not at all 100% avoidable, there are ways to alleviate it. For instance, if Y and Z are the dominant rotations for the character's arm, let's say this is an arm, we can go in and change the rotation order from XYZ to YZX so that it will evaluate those two rotations first, and then the less dominant rotation down the axis of the joint last. Let's go in and repeat the process by rotating it 90 degrees on Y. So we still have our X-axis as well as our Z. So there we've shown the importance of the rotation order, as well as a demonstration of what gimbal lock is and how you can help to alleviate that process. So another thing I want to talk about with a joint, the last thing actually, is segment scale compensation. Switch back to our multiple joint here. Let's hide our polygons and handles. So what segment scale compensation does, let's rotate this off axis. I'm going to select the first joint and scale it. So we can see that the second joint, the child of the first joint, retains its original scale, which is 1. So if we were to select that joint and open the attribute editor, we can see that if we scroll down to the joint, we have segment scale compensation enabled. If I were to disable that, it doesn't know how to compensate for the off-axis scale, and so we get skewed joints. Typically, you want to keep this enabled on a joint chain. I mean, there are instances where you can use it to your advantage in rigging, but it's something to be aware of. So those are the major components in joints within Maya. So now let's move on to the next section on the fundamental tools of rigging.